In this video we're going to look at DH parameters, and we're going to find out how to derive the matrix associated with the DH representation. This is thankfully quite simple to do, and I'll just show you why that is. Okay, essentially what we're doing is we're taking some coordinate system x0 corresponding to a link and then transforming it into this coordinate system. So what matrix does this transformation? The way to think about it is through this diagram. If you understand this diagram, deriving the matrix is extremely simple. And this diagram is thankfully quite simple. Basically, we've got some coordinate system with an axis Zn here and Xn here. And we want to basically map this onto this. So we want this to overlap with this by a series of rotations and translations. Okay, so we've got basically this corresponds to our link n, and this can be n plus 1. Some textbooks do n and n minus 1, it's not important. Basically you're turning this into this. So you can see the first step here, we've got xn and we want this to be aligned with xn plus 1. So we of course have to do a rotation here about the z-axis. Then we can line up our xn and xn minus 1. They're facing the same direction. So we move along by a distance dn plus 1. And we're moving along the z-axis. And then we move this along by an. And then we're left with this looking thing here. You've got the two z-axes at roughly the same point, intersecting, but they're not facing the same direction. So you have to rotate through this final angle alpha n plus 1. So essentially all we've done here is turn this coordinate system into this coordinate system by moving it and rotating it. And we can write this out as follows. So remember what we've done first. We've done a rotation about the Zn axis by an angle theta n plus 1. That's what we did here. Next step, we did a translation. So this is x, y, z, and we're doing a translation along z. Then we're doing a translation in the x-axis along here. So we've got our xn here and xn minus 1 here, so we're bumping them along like that. And so that's x, y, z again, so that's in there. And then finally we're doing a rotation about xn at an angle alpha n plus 1. And if you know your translation and rotation matrices, you can fill those in very easily. You get this huge thing here when we've filled them all in. So this is a rotation in the Zn by theta n plus 1. The way I remember these matrices is, notice for Zn, these are not multiplying the z part, this is not multiplying the z part. And notice for this one, these are not touching the x part up here, and these are not touching the x part up here. This rule works for the y as well. So that's a nice way of remembering it. So that's your rotation matrices that we've just substituted directly for that and that. The translation matrices are quite easy. In here you've got x, y, z here, so we're doing dn plus 1 corresponds to a movement in z. So that's moving in the z-axis, so you've got zn up here, moving in zn. So that goes down here. When we're moving in x, you've got that up here, x, y, z. So there's all the matrices, nice and simple. Now if we multiply all of these matrices out, very boring, tedious, eventually we get this. This is your DH representation. So if you do a DH table and get all of those values, theta n plus 1, etc., you find all of those values and you substitute that in, you'll get your transformation between one link frame to another link frame. And if you multiply all your translations together, you'll get the final matrix. One thing that is worth noting, just so you don't get confused, say you're multiplying, so you've got matrix A times matrix B times matrix C times matrix D. You have to multiply these in a specific order. So you do C times D, then you multiply it by B, so you multiply that result. That result gets multiplied by B, and then you multiply that all by a. So you have to do it in that order, otherwise you might get confused. So remember that when you're doing your multiplications. Okay, hopefully this derivation makes sense to you now, and thank you for watching.